Math 1314, Tyler Junior College, Section 2.8, Distance, Midpoint, and Circles. When is general form not a circle? Full disclosure, this video is completely optional for college algebra students. If your only concern is getting the homework questions right, getting test questions right. So skipping this video shouldn't rob you of any knowledge you need to know for whatever homework or test you're going to take. However, for those of you who are watching this video, this series, this whole series of videos, whatever, if you're more concerned about becoming a better critical thinker than just, look at me, I can follow steps and get answers to problems, or those of you who plan on taking more advanced math classes, I think this video will pay some dividends. When we were doing general form in the previous video, the theoretical mathematician in me was saying it's not always a circle, because there are conditions under which it won't be a circle. And let me kind of tell you why that's the thing. What you see here is the completing the square that was done in the previous video. I'm not going to rehash all the completing the square moves. We'll have an opportunity to do that here shortly. But we had this equation. We moved the 23 over. We rearranged pieces. We added 9 and 4 because they completed the square, and then we added 9 and 4 to the right side. And we got to standard form, and then we found the radius by square rooting this number, which happened to be 36. But what would have happened in the previous video if this minus 23 had been a plus 23? Then moving it over would have made it negative. Negative 23 plus 9 is negative 14. And negative 14 plus 4 is negative 10. Do you see the problem now? If that 23 had been positive at the beginning, to get the radius, we would have had to solve r squared equals negative 10, square root both sides. This is not real. Since our graphs live on a coordinate plane, which is really just two real number lines, then it doesn't make sense for a circle to have a negative radius, especially since radius is a distance, aka a positive real number. So there exist scenarios where when we attempt to find the radius, we can't, or at least we can't find a real radius, which shuts the problem down. So this kind of raises a question from a theoretical perspective. Is there a way to predict in advance from general form if this is going to happen? Of course there is. What is it? Let's find out. Let's start with a general form that's generic. X squared plus y squared plus ax plus by plus c is equal to 0. This is how you answer questions generically. You remove specific values, replace them with variables, replicate the procedure, and find the problem. So let's say that we're going to attempt to find the standard form for this, and we have to do the same thing we did before, which is complete the square. So let's get the x terms together. There's x squared plus ax. Leave a blank to complete its square. The y terms together, plus y squared plus by. Leave a blank to complete its square. And at the same time, move the constant c over here, make it negative. And notice I left some space in front of it because I know I'm about to add things to both sides. So I'm going to put them in front of that c. Well, what are we going to add? Well, don't be intimidated by completing the square generically. Just follow the procedure. To complete the square, you take half of the linear coefficient, so half of a, which is a over 2, and then you square that. If I square a over 2, I square both sides, and I get a squared over 4, which is what I would add to both sides, plus a squared over 4. And then I would do the same thing for the y's, but it's just a b instead of an a, so if I changed all the a's to b's, it would be plus b squared over 4, which is what I would add to both sides. Should I factor the left? That's not where the issue arose. The left will factor. If you really want to try to factor it, do it, but if you were paying attention last video, it's not as hard as it sounds. The issue was over here. Because remember, this mess over here was eventually what the radius squared was equal to. And the problem came from when this was negative. So it's at this point we can analyze under what conditions will this be a circle and will this not be a circle. In order for this to be a circle, we need this number to be a positive number. So, general form, which I'm just going to put as GF, is a circle when this expression is positive. A squared over 4 plus B squared over 4 minus C is greater than 0. Now, we didn't talk about the one case where it is 0. If it's greater than 0, we square root it, we get a radius, no problem. If it's less than 0, we square root it, we get an imaginary number that's not anything. It's not a graph at all. But if it is 0, what does it mean for the radius to be 0? Well, you start at the center, and then you go nowhere. A circle of radius 0 is a single point. It's often called a degenerate circle. So we can say general form is a single point when this guy is 0. A squared over 4 plus B squared over 4 minus C is equal to 0. And then we can say that general form has no graph when that expression, A squared over 4 plus B squared over 4 minus C is less than 0, because that would represent the squared radius, so square rooting a negative would make it imaginary. So at this point we've actually answered the question, under what conditions will general form be a circle, be a single point because it collapses down to a radius of 0, or have no graph at all. But I would like these conditions to look a little bit prettier. So to spare you all the details, because I'm going to do the same moves on all three of these two inequalities in one equation, imagine doing two things. Number one, multiplying both sides by 4. It would kill this fraction, and stick a 4 in front of the C. And then moving the 4C over to make it positive. So if we do that, A squared plus B squared is greater than 4C, means that we have a circle. A squared plus B squared equals 4C, means that we have a single point. Or if you want to think of it as a circle with the radius of 0. And then A squared plus B squared less than 4C is when there would be no graph. Well, rather I should say no graph on a real coordinate plane. You really want to graph with imaginary and complex numbers? Welcome to 4 dimensions. Again, this is not something that as a college algebra student you really need to know. But for those of you that are future mathematicians or applied mathematicians, aka physicists and engineers, these are the types of questions you'll run across either in your studies or on your own. So it's always a good idea to try to follow through generically to draw a conclusion. So I now know when I'm given the general form of a circle, there's only certain times when it is a circle, certain times when it's a single point, and certain times when it's not even a graph at all. And for full disclosure, I did not know these things prior to or at the conclusion of the previous video. I had seen them once upon a time, never saw them again and forgot them. So I literally, I'll show you, it's over here. I literally reinvented this between videos, right there. So I'm not just blowing smoke here or saying do as I say, not as I do. Math is all about solving problems, and sometimes, as crazy as this sounds, you actually create your own problem in an attempt to see if you can solve it. By doing that, you're building sharper critical thinking skills, excellent problem solving skills, both of which can apply to other areas outside of math.